Okay, now let's go over the independent practice for Unit 3.2. For 1, 2, and 3, write each statement as a conditional statement, and then, like we did before, circle the hypothesis and box the conclusion. So roses are red if it's a rose, then it is red. Okay, that's the if-then parts that we need to make it a conditional statement. The hypothesis is that it's a rose, and the conclusion is that it is red. A triangle has 3 sides. If it's a triangle, then it has 3 sides. It's a triangle is the hypothesis, and it has 3 sides is the conclusion. Even numbers are divisible by 2. If it's an even number, then it, or the number, is divisible by 2. Okay, and a hypothesis is it's an even number, and the conditional statement is the number is divisible by 2. For 4 to 6, determine if the conditional statement is true or false. Write the converse and determine if it is true or false, and then if possible write a biconditional. So we've seen this kind of exercise before. The statement we're given is if a triangle is equilateral, then its 3 sides have the same measure. Okay, so realize that its refers to the triangle. Okay, so that's kind of important when we go ahead and we write the converse, because we're going to put what was behind after the then after the if in the converse. So if the triangle has 3 if in a triangle 3 sides have the same measure, then the triangle is equilateral. So let's write that. If in a triangle the 3 sides have the same measure, then the triangle is equilateral. Is that true or false? Well, we didn't exactly get into triangles yet, but I assure you that you may know this already, but that is a true statement. If in a triangle the 3 sides have the same measure, then it is equilateral. So we could write a biconditional here, and we can say a triangle is equilateral. That's taking the P here. If and only if its 3 sides have the same measure. Okay, good. So that is our biconditional statement. Let's take a look at the next statement. If 2 angles are vertical angles, then they, which really refers to the 2 angles, so let's kind of write that in instead of they, meaning the same thing. We're not changing the meaning here. The they refers back to the 2 angles. But it will make more sense when we write the converse. Then the 2 angles have the same degree measure. So let's write our converse. If 2 angles have the same degree measure, if 2 angles have the same degree measure, then they are vertical angles. Well, let's look at the truth or falsity of each of these statements. The first one, if 2 angles are vertical angles, then the 2 angles have the same degree measure. Is that true or false? We learned that already. 2 vertical angles do have the same degree measure, so that's true. Let's look at the converse. If 2 angles have the same degree measure, then they are vertical angles. So that means that every two angles, no matter where they are, if they have the same degree measure, they have to be vertical angles. But we know that a vertical angle is only formed when two lines intersect. And for example, if these two lines here intersect, this is a pair of vertical angles. But what about an isosceles triangle? Here's an isosceles triangle where both of the angles of the bases are equal. Are these vertical angles? No, because vertical angles have to share the same vertex, and they have to be consisting of opposite rays, right? The sides of the vertical angles have to be opposite rays. And here, we have two equal angles that have different vertices, and they don't consist of opposite rays. So you can have two angles with the same degree measure that are not vertical angles. So this is false. So biconditional cannot write. We cannot write a biconditional for that statement. Let's look at statement number 6. If two angles are complementary, then the sum of their measure of two angles' measures is 90 degrees. There is referring to the two angles. So I'm just sort of rewriting that little thing there so that when we do the converse, it will sound a little bit better. Let's write the converse. If the sum of two angles' measures is 90 degrees, then the two angles are complementary. So let's take a look at the first statement. Is this true? If two angles are complementary, then the sum of the two angles' measures is 90 degrees. Well, that's true because that's a definition of complementary angles. And if the sum of two angles' measures is 90 degrees, then they are complementary, and that's also true. Okay, so this is a statement we can write a biconditional for. Let's go ahead and write it. Again, it's P if and only if Q. That would be if two, no, I'm sorry, there's no if. Two, so there's no if before the P. Very important. The first impulse is you're going to write the if, but you drop the if for the biconditional. We just take the P. Two angles are complementary. If and only if the sum of their measures is 90 degrees. And that's our biconditional statement.